Okay, so now we're going to have a general equation here. Sorry, I have to reach through the tripod here. Ax squared plus bx plus c equals 0. So the sum of the roots is what? Can you tell me?
Negative b.
It's negative b when this front term is 1.
So b over a. Negative b over a.
Negative b over a, yeah. So the average
So negative b over 2a.
is b over 2a. And the product?
C over a.
C over a. Okay, and so what am I doing now?
So I guess first you can just divide the a through if you want, just to make it a little easier, so you have even x's.
Well, we certainly could, but we still, we would get the same sum, average, and product. So that, we could simplify the equation in the beginning, but we don't need to.
So I guess what you want to do then is you want to do your average, so minus b over 2a minus c, and then times minus b over 2a plus c.
Okay, so our roots are negative b over 2a minus z and negative b over 2a plus z.
And these multiply to be c over a.
And what do they multiply to be when I do that multiplication?
So they're going to...
Or b over 2a squared.
Okay, so that's going to be b squared over 4a squared.
And then minus z squared.
Minus z squared
equals c over a.
c over a. Okay.
So I guess we can do the same trick. We can move the z squared and then move the c over a.
Z squared equals, and I'll get a common denominator here, so I'll multiply by 4a over 4a.
So z squared is b squared minus 4ac over 4a squared.
Okay, so z equals,
It's the square root of b squared minus 4ac over 2a. And the 2a
Plus
is
or minus that.
not the square root.
that's right, it's plus or minus this. Okay, so what do my two solutions end up being?
So you're
What is one root?
So it's minus
b over
b over 2a.
minus z.
Okay, so I get, well, since I have 2a on the bottom of both of them,
We can just
I can
combine
just
them.
put minus b plus or minus square root of b squared minus 4ac over 2a. Cool, huh?
Yeah.
Okay, and now you wanted to see if this worked on complex roots. So having gone through the math, do you think it will work with complex roots?
Well, I think it will. We'll just have imaginary solutions. Like we'll have i's come out of the square root.
Okay, do you think that's okay?
Yeah. I mean, I don't see why it wouldn't, as long as like these, as long as a is non-zero, it's fine.
Okay, then let me then ask an even more abstract question. What if the a's, b's, and c's possibly were also complex numbers? Do you think this method would still work?
I think it still works as long as we don't have it divided by 0.
Ah, very good. Okay. Yeah. So this is a very general method. It relies on this idea of sum and product of roots, which is pretty cool. Do you understand the sum and product ideas and where that comes from? Okay. How about you? What do you think of this method?
It's pretty neat.
pretty neat.
It's kind of easier than the usual method.
Yeah, well, it's definitely a neat way to think about it. And those ideas of sum and product of roots are pretty important. All right, hey, good work, guys.